Hello and welcome. So in this session, we are going to talk about broadcast variables. So let me try to explain it with the help of an example. Uh, Imagine there is a new movie that just came out, okay, that's just released. And let's say the movie is released only in one city. Let's say it's released only in Mumbai. Whoever wants to watch this movie has to travel to Mumbai, watch the movie, and then come back. Do you think that's an efficient way of, letting people watch that movie? Not really, right? And hence, the movie is released almost in every city, closer to people who want to watch it, which means people can go to their local theater, watch the movie, and come back. It saves a lot of traffic, it saves a lot of cost of people traveling to Mumbai, and it saves a lot of other problems, right? Uh, Broadcast variables actually solve a very similar problem within the architecture of Spark. In fact, it's not only in Spark, right? In almost every technology, in almost every data sharing platform, this is the kind of strategy that's used. You don't keep data at one central place, right? If there are a lot of consumers of some data, you don't keep data only at one central place. You kind of distribute that data across different regions, different geographies, so that people closer to a particular place should be able to fetch that data from their local server. YouTube does the same thing. Basically, YouTube has caching servers across the world. Any video that you upload on YouTube is not available on just one server within the YouTube infrastructure, right? The video gets actually distributed across different caches in the world. And when you actually watch a video, it is served from a very uh, closer server to you where that video is present. Right? So broadcast variables solve a very similar problem where, let's say, you have some data, okay, which is going to be required by a lot of tasks within your data processing. Okay, now this data, if you just keep it with the driver or with the master, then every task will have to come to the driver to access that data, and then it's gonna create chaos. And hence, what Spark does is it lets you broadcast some data, which means it lets you send some data closer to the tasks. And that's what broadcast variables are in Spark. So they are read-only shared variables, which means people can only read that data. They cannot modify that data, because if different tasks start modifying this data, then it will be again a chaos, right? Different tasks will have different copy of the data, and then you don't know what's happening. Uh, so what happens is from the driver, whenever you create a broadcast variable, it gets transferred to all the worker nodes, okay, and all the worker nodes will have a copy of it locally, so that the tasks that are running on that worker node can access that data from the local copy rather than going back to the driver each time. Now, it sounds very simple, and I'm sure a lot of people already know this, that this is how broadcast variables, are used. But there are some internals that I'm sure many people don't know. So I'm going to talk about those internals as well. In this session, I'm not going to do hands-on. I'll record another video for hands-on session, because the internals that I'm going to talk about, in this session for broadcast variables are very, very important. And I can guarantee you, you won't find those internals anywhere else. First thing, a lot of people think that there is only one copy of a broadcast variable per node, which is not true. Actually, there is one copy of a broadcast variables per executor. The thing is that every executor within Spark runs in its own JVM, right? So if there are multiple executors running on the same node, same worker node in Spark cluster, those executors are not really sharing any memory space, right? They are running within their own JVMs. So if there are 3 executors running on one node, there are 3 JVM processes running on that worker node, right? So which means every executor will have its own copy of the broadcast variable. Make sense? Second thing, how does Spark actually really transfer the broadcast variable to different executors or nodes, right? There is always a talk of that Spark makes it very efficient. I mean, if let's say an executor requests variable from the driver, that would have been a little more inefficient But the way Spark does, broadcast the variables is really, really very efficient. And that is the uh, internals that I'm talking about, right? These are very, very important internals. And if someone asks you in an interview, how does Spark distribute a broadcast variable across the cluster? Then this is what you need to explain. Basically, what Spark does is it uses a BitTorrent-like implementation. If you're not familiar with BitTorrent, let me just explain that to you. So you have a large chunk of data, a file or data in any form, in the form of a data structure, right? And you want to transfer this data to, let's say, thousands of consumers, right? If you start transferring this data to thousands of consumers from a single server, then that server is going to get, choked. So what happens is you basically divide this large chunk of data into small blocks. So in this case, for example, if you see, let's say M is your broadcast variable, you divide M into smaller chunks, M1, M2, M3, M4, and then uh, you transfer data to different consumers in the form of chunks. So for example, let's say executor 1 got the chunk M1 and M4, executor 2 got the chunk M2, executor 3 got the chunk M3 from the driver. Now, when these executors know that they still need more chunks to complete the variable M, so what they can do is they can look for these chunks not just from the driver, but they can look for these chunks from other executors as well, which are probably closer to them than the driver. So driver might be running on one node. Let's say all these three executors are running on one node, right? If all three executors transfer all of their data from the driver, then basically three copies of M are being transferred from driver to the same node, right? Which does not make sense. So in order to make it more efficient, what can happen is, let's say these executors fetch individual chunks from the driver, but those chunks are not common, right? So no, two executors are not fetching M1 from the driver. If one executor has fetched M1 from the driver, other executors on the same node do not need to fetch M1 from the driver. They can fetch M1 from this other executor, right? So which makes it much, much more efficient. And that is how the BitTorrent implementation works, where you have a, let's say, large movie divided into smaller chunks. People are downloading that movie through BitTorrent. They are basically downloading those chunks, but they are not downloading those chunks from a single server, right? A single source server. People are downloading from each other and they are uploading to each other as well at the same time, because the movie is divided into chunks. So that makes the transfer of broadcast variables very, very efficient. And this is the right answer to explaining how exactly Spark makes the distribution of broadcast variables efficient. So in the next lecture, we are going to do some hands-on on broadcast variables. We'll look at a use case, how broadcast variables can be used to solve particular problems in your use cases. So that's it for this session. Thank you very much. I just have one request. If you like the stuff that I'm posting, please subscribe to my channel. That will motivate me to upload more stuff. Thank you very much.